Hello, my name is Kevin Fryar, and today's talk is geostationary satellites, tools for you and a meteorologist. Now for today's agenda of topics, I'll give you an introduction to myself as the meteorologist. We'll talk about the geostationary satellites and where they impact your life and the importance of geosatellite data, and we'll talk about some very key examples that are in everyone's lives. Whether it's fire, we're going to talk about hurricanes, a little bit about aviation. We'll talk about floods, severe weather, and we'll also talk just a little bit about space weather. And then more importantly, we're going to get a chance to talk about the future of geodata and how GeoXO is going to introduce some new instruments and further improve our ability to forecast these weather events. So a little bit about me. As you can see, I'm a meteorologist. I've been a meteorologist for my entire professional career, up until recently, where I'm now acting as the Chief of Staff for the Geostationary program for satellites, for weather satellites in particular. Weather satellites are probably the greatest tool any meteorologist will ever use. I've been fortunate enough to be involved in weather to a point where I'm either forecasting for it, obviously living in it, and in some cases even flying into it as well. But now my job is to be able to observe it from a geostationary orbit, and I'm going to show you how cool that can be in terms of the instruments that we have and the capabilities that we have as well. So when we talk about NOAA's geostationary satellite system, in particular, we're talking about a system that is providing us with eyes in the sky. Now this particular image shows you Galveston around circa 1900. And during that time frame, we had a tremendously devastating event. And the caption for this particular picture comes from Lewis's book, The Fifth Risk, in which we actually can say we ran a no satellite experiment in Galveston in 1900 and 10,000 people died. Now, thankfully, we can say that we should never have that experience again. And a way to point that out, former director of the Hurricane Center, Bob Sheets, says the greatest single advancement in observing tools in tropical meteorology was unquestionably the advent of the geosynchronous meteorological satellite. And so we thank him for making that point, because that is exactly why we have this particular system in place. Now, when we look at NOAA's GOES constellation, it consists of 2 satellites. Now, I'm going to use a lot of terms throughout this entire presentation, so first let's define what geostationary means for satellite systems. This animation will show how geostationary satellites work. Geostationary satellites orbit more than 22,000 miles above Earth's equator at speeds equal to Earth's rotation, which means that they maintain their position and provide continuous coverage over a region. Now, NOAA maintains a 2-satellite operational constellation. Together, they're known as GOES East and GOES West, which they're able to watch over half of the globe, from the western coast of Africa all the way over to New Zealand, and as far north as the Arctic Circle down to the Antarctic Circle. Now, GOES 16 was launched in 2016 as the operational GOES East satellite, where it's currently located at 75.2 degrees west longitude. GOES 17 was consequently launched in 2018 and is the operational satellite GOES West, where it is located at 137.2 degrees west longitude. Now let's talk about NOAA's satellites' impact to our daily lives. Aside from natural disasters, GOES provides the ability to monitor the dispersion of smoke and dust, which can improve air quality warnings and alerts. Now, when this information is coupled with the detection of low clouds and fog, these parameters can be used to improve transportation safety and enhance optimal aviation routes. GOES can also be used to monitor better solar particles that may pose a radiation hazard threat. Now, when we break it down in terms of benefits and applications, the list is long, but we'll go to some of the more appropriate ones, which are improved hurricane tracking and intensity forecasts, the increased ability to forecast thunderstorms, tornado warnings, and increase and improve lead time, as well as early warning of lightning ground strike hazards. Now, we'll also talk about how it's better at detecting heavy rainfall and flash flood risks, as well as fire detection and intensity estimations, and the ability to improve the detection, again, of low clouds and or fog, which will improve transportation safety and aviation overall. One of the other benefits is that it improves warning for communication and navigation disruptions for power blackouts. Now, how does NOAA's data reach us? Well, it reaches us in a number of ways. And in particular, we see it every single day on our television and on our phone. We actually use this satellite data every single day. And what would the world look like without satellite data? Well, just remember that over 90% of that data goes into our weather models from our satellites. So GOES provides the ability to improve our weather forecasting as well as monitoring the atmosphere for a variety of environmental hazards. Now, some of the weather applications that are most prevalent that you're going to see every single day and think about will be that cloud imagery where you're looking at hurricanes moving across the Caribbean, or for lightning detection. So some of the things that we can talk about very specifically that are an incredibly unique feature of GOES because of its advanced technology is its ability to detect fires. And in particular, GOES East is able to see the deadly campfire. Now, GOES East was able to capture this particular imagery in Northern California on November 8th, 2018. Now, the wildfire developed in the early morning hours and spread quickly within very windy and dry weather conditions. Now, these hot spots and the large plume of smoke were seen with the fire temperature, or the RGB imagery, which stands for red, green, or blue. And this was created through the imagery bands 6, 7, and number 5. Now, we use these particular bands to detect hot spots. And in this particular animation, we were able to capture those particular fires and show how they actually will pop on satellite imagery. Now, another example of a feature, or more importantly, things that we monitor with GOES are going to be hurricanes. And in this case, let's actually focus in on Hurricane Fiona as it left its wake of destruction across the Caribbean and the Atlantic. So GOES East was able to monitor Hurricane Fiona's development from Guadeloupe to its dissipation up and over Canada. The storm caused devastating flooding and damaged critical water and power infrastructure in its wake, with sustained winds near 130 miles per hour. So Fiona headed northward toward Bermuda as a Category 4 hurricane. Now, NOAA satellites were able to provide vital data and information for forecasting that hurricane, and again for being able to monitor its overall location, movement, and the overall intensity of the storm. So for Hurricane Fiona, some quick details. It was the first major hurricane and storm of the Atlantic season. It wreaked havoc across, again, the Atlantic, creating catastrophic damage for Puerto Rico, the Dominican Republic, as well as the Turks and the Caicos. So Tropical Storm Fiona first formed in the central Atlantic on September 15th and passed just north of Guadeloupe on September 16th, where one person was killed. And then it entered the Eastern Caribbean. On the 18th, Fiona strengthened into a hurricane as it approached Puerto Rico and made landfall later that afternoon on the island's southwestern coast. By imaging a storm as often as 30 seconds, these satellites can help provide forecasters the ability to easily discern the movement of cloud features and also provide greater confidence in estimating the center of the storm. So another capability is being able to monitor floods and severe weather. And in this example, we'll talk about the storms that affected Kentucky and Missouri with flash flooding. Now, even though these storms were hundreds of miles apart, they were connected in the same weather system. And as a result, urban St. Louis and rural Appalachia were experiencing the same devastating flash flooding. NOAA satellites were able to monitor the storms that produced this catastrophic flooding. GOES-16 in particular provided imagery that captured the detailed information about cloud properties in near real time, including the presence of overshooting tops and gravity waves, which are indications of a storm that may turn severe. Now, infrared imagery provides information as well, specifically to the temperature of those cloud tops. The colder the cloud tops, the more likely the storm is producing heavy rain and severe weather. Now, in the case of flooding is responsible for the most loss of life and property compared to any other weather event in the United States. And to determine which areas are affected most, GOES imagery and imagery from other satellites were combined to create comprehensive flood maps. And these maps were used by FEMA and first responders to decide where their efforts should be focused and where they should deliver their limited resources. So the comprehensive flood maps also revealed where flooding was receding, which helps officials continue to decide when and where residents can safely return to their homes. So in this case, in Missouri, as well as in Illinois, the first batch of downpours on Tuesday and Wednesday of July 26th and 27th dropped a large amount of rain, a huge amount of rain in some places, up to 10 inches. And another 2 to 4 inches fell the following day on Thursday. On July 28th in eastern Kentucky, 8 to 10.5 inches also fell. So one of the other features and capabilities of GOES is its ability to image the sun. So solar imaging and space weather monitoring are a feature that we're just now getting not only an understanding, but an ability to pass that information along to decision makers. And in particular, the GOES-18 SUVI, or solar and ultraviolet instrument, is able to capture a tremendous amount of, we'll call them events, and also properties of the sun. And in particular, a coronal mass ejection, which is commonly called a CME, was captured on July 10th, 2022. And the sun as seen through SUVI's 6 extreme ultraviolet channels was able to produce, as you can see, these lovely images here, an idea of what a coronal mass ejection both looks like, and then we were able to detect its overall impact here on Earth. On October 28th, 2021, GOES-16's SUVI, or solar ultraviolet imaging instrument, was able to observe a strong solar flare. Now, this flare produced an actual aurora that could be seen, and remember, aurora is actually called the Northern Lights, that was actually visible not only in Canada, but as far south as Pennsylvania, Iowa, and even in portions of Oregon. Now, solar flares are an important type of solar weather event, but they're also very localized. They're explosive outbursts from the sun that can generate intense radiation in the form of X-rays, and the energetic particles that can sometimes affect Earth. Because the radiation often travels at or near the speed of light, it can reach the Earth within 8 minutes. But flares are often linked to eruptions called, again, coronal mass ejections, which can hurl these massive amounts of clouds of magnetized plasma as far into space, plowing right through what is normally known as the solar winds of the continuous flow of charged particles. And that solar wind, once disrupted, can reach the Earth and is up to as quickly as within 3 days. So how does GOES actually help monitor that, and what does that actually mean for the GOES satellites? Well, we monitor that activity, whether it's solar flares or CMEs, to provide decision makers with the information to know that there is a solar flare or there is going to be a solar eruption that can disturb either ground infrastructure in terms of power or in some cases communication. So now we can talk a little bit about some of the societal vulnerabilities of environmental hazards and how GOES continues to help mitigate those. As society becomes more vulnerable to environmental hazards, the ability to predict and monitor these events becomes more essential. Now we can see the average number of events in a year and the associated losses increasing over time. And if we list factors for that, the most important ones that we can see are for the increased vulnerabilities are going to be increasing population in these vulnerable areas, as well as infrastructure that's at risk during these extreme events. Now, the signs of climate change that are most notable and that we do talk about are sea level rise, as well as the increasing extreme precipitation events. Now, again, it's not all bad news. We have the ability to monitor and see a lot of these different events. But because of our increased skill, technological advances, with our satellite constellations, with GOES, we're able to predict these events. And we can actually predict them as far out as 1 week, which gives us time to plan. And this is all in an effort to make sure that we never have a Galveston outcome again. Now, when we talk about reminders for the need of continuity of operations, clearly I'm not one that needs convincing. I understand the need for weather satellites. But events like flooding, thunderstorms, and fires, they all provide advocates with evidence that we need to continue this capability. And when we talk about the capability going forward, we're talking about the ability to not only look at our side of the world, but the entire world. And what you're seeing here is a view of the geo-ring of meteorological satellites that are contributed not just by us, but also by Europe and with Japan. So this is how we can actually see the entire world from this particular orbit. Now, when we think about being able to work with our partners, we also have to think about the future. And we think about what the mission needs. So the next generation of satellites, well, we're going to build on the existing performance, and we're going to meet the requirements with new observations. Now, these new instruments will be enlisted to provide improved forecasting, climate monitoring, ocean features, and also be able to use new instruments like an infrared sounder, instruments that are able to measure ocean color as well as atmospheric composition. Now, the current GOES-R series will monitor and continue to watch the skies for some time. But when we talk about the future, well, how soon is it? Well, the first GeoExo satellite is planned to launch in 2032. But by 2036, NOAA expects to launch a second satellite that will contain the sounder that we just talked about, as well as the instrument that's going to measure atmospheric composition. The third satellite will launch with another imager on board and with the ability to map lightning as well as look at ocean color. And these satellites are designed to observe for the next 10 years and then to be replaced by 3 new satellites which will observe for another 10 years. So until then, GOES-R will be our eye in the sky. Thank you.